Welcome to this video on structural analysis. Today we will be exploring the effects of temperature changes on arches. First, consider a three-hinged parabolic rolled steel arch with a span of 24 meters and a central rise of 8 meters. We need to determine the change in central rise for two thermal cases, a temperature increase of 30 degrees Celsius and a temperature drop of 20 degrees Celsius. The coefficient of thermal expansion alpha is 12 times 10 to the power of -6 per degree Celsius. Let's look at the formula and calculation. For a three-hinged arch, the change in central rise is given by the formula L squared plus 4yc squared divided by 4yc, all multiplied by alpha times T. For a temperature rise of 30 degrees Celsius, substituting 24 for span L, 8 for rise yc, alpha, and T equal to 30, yields an upward deflection of 9.36 millimeters. For a temperature drop of 20 degrees Celsius, substituting T equal to 20, yields a downward deflection of 6.24 millimeters. Notice how thermal expansion increases crown rise, while thermal contraction decreases it. Now let's examine our second problem involving a two-hinged reinforced concrete arch. The arch spans 42 meters between hinges and features a central rise of 7 meters with a parabolic profile. It has a rectangular cross-section measuring 120 centimeters by 40 centimeters. Our goal is to calculate the increment in horizontal thrust caused by a temperature rise of 24 degrees Celsius. The Young's modulus E is 3 times 10 to the 4th megapascals, and alpha is 11.2 times 10 to the power of -6 per degree Celsius. First, we calculate section properties and arch geometry. Section inertia I equals BD cubed over 12, giving 0.0576 meters to the 4th power. Modulus E is 3 times 10 to the 10th newtons per square meter. The parabolic height equation Y simplifies to 1 over 63 times open parentheses 42x minus x squared close parenthesis. The additional horizontal thrust H1 equals L alpha TEI divided by the integral of y squared dx from 0 to L. The numerator calculates as 42 times 11.2 times 10 to the -6 times 24 times 3 times 10 to the 10th times 0.0576. The denominator integrates open parentheses 1 over 63 times open parenthesis 42x minus x squared close parenthesis squared dx from 0 to 42. Evaluating this yields an induced horizontal thermal thrust H1 of 17.77 kilonewtons. Thank you for watching. We have successfully evaluated the vertical displacements in a three-hinged arch and the induced horizontal thrust in a two-hinged arch under thermal changes. Keep practicing these thermal stress concepts, and I will see you in the next lecture.